Why do crocodiles bask along the riverbank with their mouths open for no apparent reason? When biologists wanted to understand this phenomenon, they began recording and tracking as many variables as they could think of in search of the answer. Was it related to time of day, recent feedings, gender, temperature, or humidity? Through application of the scientific method, it was discovered that it is most likely, though not definitively, related to temperature control. While there are still some mysteries as to why they do it in the manner that they do, powerful discoveries have been made through tracking the variables of crocodiles' actions and environments. Similarly, when astrophysicists search for certain types of invisible stars, they find them through tracking the actions and behavior of celestial bodies that surround them. In fact, when any scientist wants to make a discovery of any kind, the process is always the same: record variables and track behavior. In this way, patterns are recognized. Now, what if an Egyptologist wanted to conduct research on the behavior of certain attributes or scene types within a temple, such as the appearances of the Nemes headdress with a flanking apron in wine offering scenes at the Temple of Medinet Habu? This entails acquiring the images, through publications if fortunate, or via direct examination. Even with the fantastic recent availability of digitized versions of the Oriental Institute Epigraphic Survey volumes, we would then have to go through the laborious process of systematically examining each plate to determine where the variables appear. And what if, several hundred plates in, an additional variable catches the eye? What if it was recognized that a vulture hovers over the king's head in many of these scenes, but the specific variations hadn't been tracked? If it was decided that that variable needed study, we would have to repeat the entire examination of the plates. This type of epiphany can occur several times. It happened to me quite a lot during this process. Although an essential part of such a process, this requires a great deal of additional work on the researcher's part with each additional question. This extended process is certainly capable of producing insights, but it is time-consuming and inefficient. So what is missing from this picture for Egyptologists and art historians in general? We have not yet joined our academic brethren in recording and tracking variables in visual material. Instead of going through our traditional laborious methods, we could use one of the tools developed in this project and press a button to efficiently reveal the occurrences of all attributes of interest, and in a matter of moments, revise that search in myriad ways to identify the various scenes in which they appear in pairs or even triads. I can demonstrate how art can be counted, which allows it to be quantified, discuss the many benefits and types of revelations that this counting approach can bring, and outline the future applications of this process and their implications for Egyptological and art historical research. In short, I propose that rather than dragging the data where we want it to go, we instead allow the data itself to lead the way. Before we go any further, there are a few points regarding my background that are pertinent. I am not a mathematically minded person. To be frank, I'm the type that goes a touch catatonic when presented with the Pythagorean theorem. I have no background in statistics. The closest I have come to statistics outside of this project has been to track the foods I give my toddler in the hopes of determining what has the greatest correlation to diaper rash. Prior to this project, I had no experience with either database construction or any of the software that has been used to analyze the material. Although this endeavor has required research outside of art history, much of the reading has been at the layperson level. My reason for stating these facts is to clearly demonstrate that there really are no major barriers to using this methodology for even the most numerically challenged, provided you are willing to study enough to understand the concepts behind the statistical output. When I presented the initial stage of this project at the American Research Center in Egypt conference in Toledo in 2007, I had recently returned from data collection and had only developed the templates for data entry. Since that time, this dissertation project, a study of the memorial temple of Ramses III at Medinet Habu, has been focused on the many available types of statistical analyses to identify those that are most effective for the investigation of visual material. Verification for the validity of this approach and the potential benefits it can bring to art historical research has been successfully achieved. In conjunction with my analytical partner, I have been able to discern what statistical methods are most useful for our applications. As the case study carried out from my dissertation clearly demonstrates, This process has proven its worth. My goal in presenting the mature process is to introduce our field to a proven method for investigating iconography, and to hopefully excite you with the possibilities that this model can provide for your own research. Now that the methodology has been developed, data entry is the primary barrier in this process, and it's really not much of an obstacle. Now, how does the data entry work? The basic process is simple. When initiating data entry, the first step is to do a thorough visual survey of the images. This allows the researcher to come up with a large number of possible variables to track. In the beginning, I tracked more than 1,600 variables. These are obviously of great specificity, such as noting variations in the protective texts that appear behind the king. Since we never know what patterns are going to emerge, there are advantages to going this route. A large number of variables have the benefit of allowing the discovery of quite obscure patterns. For instance, if you were researching Rembrandt portraiture, a single variable of hands visible would not necessarily show a pattern related to a particular gesture and the occupation of the subject. Instead, it would be desirable to have specific gestures and hand positions identified as different variables so that variations could be recognized. Recent confirmation regarding the physical ailments of Tutankhamun, specifically his clubfoot, suggests other reasons to track subtle variables of this nature. In some of his images, the king is depicted leaning on a staff, or with his leg bent, so as to take weight off his foot. These body positions have now been shown to have had basis in reality, and actually convey something specific about this king. Having variables to record various body positions and gestures could help identify other such cases. However, more variables inevitably translate into increased data entry time. Choosing what variables are the most efficient and effective to track is one of the biggest issues in this process. What questions can be asked about a corpus of scenes that gives the most bang for the buck? It is necessary to pare the huge initial variable list to the point where it becomes quick and easy to enter data. A cost-benefit analysis was performed to determine the ideal number of questions that provide a good balance between entry time and desired results. Utilizing a binary entry template, which includes approximately 130 variables, I am able to enter the data for a scene in about 2 minutes. Several new designs are underway, each representing phased concentric layers. Entering the group A variables for a scene will take less than a minute, versus the nearly half hour it takes to completely enter a scene into the full template. This is why there are fewer than 120 records in the full template, versus nearly 1,000 currently entered using the binary template. So, what is a binary data entry approach? Simply put, all questions must be 1 or 0. And there's good reason for this. Once images have been rendered into yes-no questions, such as, is the king holding a bow? Or, is a deity present? Then they can be searched and analyzed. Database searching can be extremely productive if you have a specific line of questioning in mind. For instance, if you wanted to search for all the variations in wine offering scenes, the search could be initiated by looking at all of the examples. Then, with a keystroke, the database provides the ability to add or subtract additional variables, one at a time or in groups, to search for in conjunction with wine offering. This type of searching is as easy to perform as a Google search, and allows for unlimited variations of that path to be explored. As far as statistical analysis is concerned, unless you choose to, the art historical researcher doesn't have to go near the statistics beyond understanding what the output is telling you. Rather, approach the statisticians and data analysts in your university. Many will be happy, and often eager, to analyze the data if you enter it and bring them the data file. The idea of aiding the deeper understanding of artistic imagery, and ancient Egyptian iconography in particular, is immensely appealing to many. Every single professional data analyst or statistician who was approached in the course of this project was extraordinarily eager to lend their time and knowledge to this endeavor.